Well, a warm welcome indeed to anyone joining. Thank you for being here. Go ahead and get yourself ready with a notebook, a pencil, or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today, we're going to take a look at this concept in calculus called the Mean Value Theorem. We're going to use the Mean Value Theorem, but first we're going to describe a little bit about it. Also known as MVT, that is the abbreviated version of the Mean Value Theorem. Something you need to know about this theorem, because there are several theorems in calculus that you'll see, is this is what I consider to be a derivative theorem, which means two things. One means that it requires differentiability to be true. So it has to be a continuous and differentiable function over the interval. But also, it means that the statement that we're going to use, or the equation that we're going to use, is going to involve the derivative. So it's sort of like it's saying something about the derivative. It's concluding something about the derivative. And let's break down what exactly it's concluding there. So we use this word mean in mathematics. What does mean normally mean? Well, mean normally means average here. So average, what are we talking about? Well, we're talking about derivatives, which is a slope. So we're really talking about the average slope, and that's why it's called the mean value theorem. It's saying that the average value of the slope, in other words, the average slope, is at some point equal to the exact or tangent slope, which we also just call the derivative at a point, maybe you would say. Derivative at a point. Okay. So how exactly do we use this? Well, it's very simple. The average slope, or the average rate of change, is something you should be very familiar with. F of b minus f of a, also known as y2 minus y1 over b minus a, which is the same as like x2 minus x1, equals the derivative. And this is the equation that you need to be able to set up every time. Once you've confirmed that the function in question is indeed differentiable over the interval that they give you. So let's see how that works for a couple of examples. We're going to start off with this here, which is just a cubic polynomial. And the way that they'll phrase the question, I might as well give you the heads up on that. A lot of times they'll phrase it in the following way. They'll say something like, find the value. Sometimes they'll say, find the value C. And then sometimes they'll say like, A is less than C is less than B. They won't always say it like that, but that's what you should kind of realize that they're asking you. They're saying what value between A and B satisfies the mean value theorem. They'll kind of just phrase it like that. So find the value, sometimes they'll say which satisfies the mean value theorem. If they're being very direct, they'll just simply say, find the x value, which satisfies the mean value theorem. Notice that we're given an interval for this. So we're looking specifically on this interval. There's some average slope on that interval. We don't need to know exactly what the function looks like. But if we were to get an idea, something like this, we might be talking about like from here to here. And so the average slope would be that. And the spot where the tangent slope matches that looks like it would be somewhere around there. So what we're doing here is we're setting this slope of this line equal to the derivative, which can constantly change. And if we set it equal, then we're basically locating this x value here. This is my C value. Here's my A, and here's my B. So this theorem guarantees that we will have at least one point where the tangent slope is parallel. And so the way to find which value satisfies the theorem is equivalent to finding the x value where the tangent is parallel which is where the equation comes from, where we're setting this slope equal to the derivative, and by solving that equation, we're finding the x value where it's true. Okay, so let's go ahead and find the average slope on the interval. That's going to be g of 2 minus g of negative 1. Be careful when you're working with negatives. Over 2 minus negative 1. Again, be careful when you're working with negatives. So this is going to be 2 cubed minus 7 times 2 squared. We're just plugging in the 2. That's easy enough. And then we're going to subtract what we get when we plug in a negative 1. So negative 1 cubed. Again, be careful with those negatives. It's easy to trick students that are not working carefully by using negatives, especially when the formula itself has minuses in it. So this is 2 plus 1. And let's work this out a little bit. So we have 8 minus 7 times 4 minus 2 plus 4. We can simplify that in a moment. Minus negative 1 cubed is negative 1. Negative 1 squared is positive 1, but if we multiply that to a negative 7, it becomes negative 7. This becomes plus 1 and plus 4. So we're being very careful here not to screw any of this up. So negative 1 and positive 1 cancels. We have 8 minus 28, so that's negative 20, plus 2, that's negative 18, minus, what do we get here? Negative 7 plus 4 is negative 3. And this is all over 3, so we have negative 18 plus 3 over 3, so this is negative 15 over 3, or negative 5. That is the value of the slope of the line that connects those 2 points. So my diagram is obviously not correct. There are some different locations that they're looking at here where the slope is a negative 5. In fact, maybe it's something like oops, don't want to delete everything. Maybe it's something like this point here. Maybe that's my b. And the slope between these two is like pretty negative, pretty starkly negative. And so we're looking for a point on the curve that has the exact same sort of slope. Okay, so we should find a spot between negative 1 and 2. I know I squished them really close to each other, but we should find some spot between negative 1 and 2 that has the exact slope of negative 5. So how do we do that? We say negative 5 equals g prime. We want to find when the derivative is also equal to negative 5. So we have to use the derivative. We didn't take the derivative, so let's take a moment to determine that. G prime of x equals, well, this is simply some power rule business, 3x squared minus 14x minus 1. All right, and this is not going to be an obvious one to solve, I don't think. Let's set this equal. 3x squared minus 14x minus 1. Let's get everything on one side because now this is a quadratic equation. Whenever you have a quadratic equation, you want to get everything to one side and factor it if it's easily factorable, or we can always rely on good old quadratic formula, which that's just like the bread and butter at this point. So 0 equals 3x squared minus 14x plus 5 on both sides. Be very careful about that. So this is going to become plus 4. Okay. And we could try to factor this. It's possible that it factors, but really what I would rather do is simply use the quadratic equation. So x equals positive 14 plus or minus the square root of negative 14 squared minus 4 times 3 times 4 all over 2 times 3. (14 plus or minus, this square is 196, and we're subtracting 48 all over 6. Okay, these numbers are not the nicest, cleanest to work with, but it's really not anything back-breaking here. 148 over 6. We can clearly take a 4 out of that, which means we can take a root, a 4 out of that rather, and that leaves us with 37. Now, 37 does not break up anymore. So we have two options to consider here, guys, because we have a plus or minus situation. So 14 plus 2 root 37 over 6, or 14 minus 2 root 37 over 6. Well, let's think about this like kind of logically to guesstimate what this is. Square root of 36 is just 6. So square root of 37 is like just a little bit more than 6. 6 point something, right? It's not even 6.1 actually. It's like 6.08 or something. I don't know. But we can say it's a little more than 6. So that means 14 plus 2 square root of 37. It's almost 14 plus 2 times 6. So it's a little more technically, but it's almost 14 plus 12 over 6, which is 26 over 6. We can call this 13 thirds if we want to reduce that, and so that means this is like 4 1/3. Well, this is not in the interval from -1 to 2. So we're not going to use this one as the correct value. Instead, we're going to do something like 14 minus 2 times 6. It's technically minus 2 times a little more than 6. So this is technically going to be a little less than, but approximately 14 minus 12 over 6, which is 2 over 6, or 1/3. And that is on the interval from -1 to 2. So this is the value which is guaranteed. I shouldn't say that's the value. I should say this is the value which is guaranteed by the mean value theorem, to have the exact same slope as the average slope between the points from -1 to 2. Okay, let's do a trigonometric example. That's going to be how we end things today. We have a function 3 secant squared of x. Now this one we have to be careful of. Be aware that this function has domain restrictions, and we need the function to be differentiable in order to use a differentiability theorem, a derivative theorem, like the mean value theorem. So let's just keep in mind that whenever cosine of x equals 0, then we know secant of x is undefined, has a vertical asymptote. When is cosine of x equal to 0, though? This is whenever x equals plus or minus pi over 2, plus or minus 3 pi over 2, etc. And let's look at our interval. Does it cross over the pi over 2? Yes, it does. Right, we have pi over 6, and then we have 3 pi over 4. If we want to get the same denominators to really compare these, this is going to be 2 pi over 12, and this is going to be 9 pi over 12. That's on the interval, same interval, but what about pi over 2? Pi over 2 is 6 pi over 12. So because we have a break in the function on the interval, we cannot use the mean value theorem. We cannot guarantee that the average slope between these 2 points, we can still find the average slope between the points. You can find the slope between any 2 points by just using the y2 minus y1 over x2 minus x1 formula. But if I want to use a derivative theorem, I need this to be differentiable. In fact, if I want to use other theorems, I need the function to even be continuous, which it's not even continuous. So I wouldn't be able to use something like the intermediate value theorem on this either. Okay, so because of that, let's not just not do a problem. Let's change the interval to one that is reasonable for us to use the mean value theorem. So let's say f of x equals 3 secant squared again. But we're going to look at the interval from maybe pi over 6 to pi over 3. Okay, so how do we set this up? First, we have to confirm that this doesn't cross any spots that have sharp corners or any spots that have domain restrictions. And we're good. We're good. We don't have to worry about that here. Let's go ahead and find the average slope. So the average slope is going to be f of pi over 3 minus f of pi over 6 over pi over 3 minus pi over 6. So 3 times secant squared of pi over 3 minus 3 times secant squared of pi over 6. You need to be good with your unit circle to be speedy and efficient and successful to a high degree in calculus. If you want to master calculus, AP calculus that is, you'll need to be pretty comfortable with trigonometry. If you're in a college calculus class, it's going to depend because there are different types of calculus. There's calculus for life sciences, there's calculus for more like engineering and physical sciences, there's calculus for business majors, which really neglects the trigonometry, rightfully so. You're not really going to use trigonometry that much in business. So if you're doing a specific level or a specific type of calculus, you may not need as much emphasis on trigonometry. But for my AP Calc students, and if you're just taking regular Calc 1 or something like that, you're going to want to be familiar with your trigonometry. So this basically means 3 times 1 over cosine squared of pi over 3. You could also use the identity tan squared plus 1 if you really feel like it. Minus 3 times 1 over cosine squared of pi over 6. And this, of course, is just going to be over pi over 6. Did I put pi over 6 minus pi over 3? Whoopsie. Those are switched. There we go. Okay, so what do we get? Cos of pi over 3, of course, is just 1/2. So we're going to have 3 over 1 over 1/2 squared minus 3 times 1 over rad 3 over 2 squared, and then all over pi over 6. So what do we get here? This is going to be basically just flip the 1/4 and it becomes 3 times 4 minus 3 times, if you flip that, that's going to become 4/3, right? Because 3 over 4, and then you flip it over pi over 6. Well, that's kind of nice that those 3's cancel. So we just end up with 12 minus 4 over pi on 6, which is going to be 8 over pi on 6, which is going to be 48 over pi. What the heck? It's pretty crazy. 48 over pi. Okay, now that is the average slope between these 2 points on this graph. We need to find the derivative and set it equal to 48 over pi. And I can tell you now, this is not going to be done without a calculator. I'm going to require a calculator here at some point. 48 over pi equals f prime. Well, what is f prime? F prime is going to be 6 secant x, and then because of the chain rule, the secant x is technically inside. We have to multiply by the derivative of secant x, which is secant x tan x, which means we have 6 secant squared x times tan x. And really, that's the same thing as just 2 f of x times tan x, but we're not going to write it like that. We're going to keep it like this, 6 secant squared x tan x. Okay, so 48 over pi equals 6 secant squared x tan x. There are going to be many solutions for this kind of an equation. It's not necessarily a really nice equation. In order to solve this, let's divide both sides by 6. We can call this 8 over pi equals secant squared x tan x. And now it would be very appropriate for us to use something like Desmos to be able to solve this. So I'm going to get sort of a screenshot of Desmos. You can graph this if you'd like. There are lots of different ways to solve this. You might remember in a video of mine that I recommend moving everything over to one side because it's a lot easier to see on the graph where something crosses 0. So if I can see on the graph where that crosses 0, and I'll show you in just a minute, secant squared x times tan x minus 8 over pi. And let's see, I'll highlight a couple of important locations here. That's not what I was trying to do. There we go. Took me a second, sorry about that. So here we have it, secant squared tan minus 8 over pi. And you'll notice that we get 3 important locations that I've highlighted here where we cross. And the reason why I've shown these 3 is because we need positive values that are between pi over 6 and pi over 3. If you don't know what pi over 6 is, that's okay. Just imagine it's like 3 over 6, which is like 1/2, basically, and 3 over 3, which is like 1. Now, some of my math comrades would crucify me if they heard me talking about pi like that. How dare you use 3? What are you, an engineer? But this is giving us an idea of where we should expect the values to fall, roughly, between 1/2 and 1. So if we take a look at our graph, the one which seems appropriate here is going to be 0.84394. Notice that there are many different values, and sometimes there are multiple values within the interval. We're only guaranteed at least one. You could have more in there if it's a certain type of function, if it's a special type of function, but in general, we're just looking for one. So here we would say C, or x, equals 0.844. Okay, so we mostly did just a basic application of the average rate of change. Then we took a derivative, which is like an early calculus step. The beauty of this theorem is that we get to set those equal to each other, and whenever we have an equation like this, we can solve it. The mean value theorem guarantees one solution on the interval. Maybe more exist, only one is guaranteed. Yeah. Okay, so this is a little bit about how you use the mean value theorem. It's very simple as long as you check to make sure that the function is given on a valid domain where it's differentiable. If you can confirm that, it really is as simple as setting the average slope formula that you've been doing since like Algebra 1 days equals to the derivative, which is something that you've learned now in calculus. Okay, I think that's enough blab out of me on this mean value theorem. I'll see you guys next time.